question asks you to implement a stack using queues. So we'll start off by describing what the difference is between a stack and a queue. So with the queue, you'll commonly hear the term FIFO. This means first in, first out. And what that means is the first element that was added will be the first one removed. So you can picture this as like waiting on a line. Let's pretend this is the entrance. This is the first person to arrive. This is the second person to arrive. This person's the third, and this person's the fourth. Which one's going to be let in first? The one who arrived first. And then the next person who arrived right after that, and so on and so forth. Let's move over to a stack. Stack is just the opposite. It's LIFO, so last in, first out. So with this one, you can picture a stack of dishes. So these are just, let's say, 4 plates stacked on top of one another. Which one are you going to take first? You're going to take the one at the top. Then you're going to take the next one that's at the top, next one, and the next one. All right, so just to demonstrate that to you in another way, this is the queue over here. First element's added, second element's added, third element's added. Which one's going to be removed first? The number 1. Which one's next? The number 2. Which one's next? The number 3. Move over to a stack. Number 1's added first, then number 2, then number 3. Which one will be removed first? The number 3, followed by the number 2, and then the number 1. All right, so back to the question at hand. How do we implement a stack using queues? There are actually a couple different methods, about 3 different methods, but this video is just going to be going over what's called the costly push method. There are a couple other methods that I won't be talking about in this video, but they're linked down below. So how do we actually implement the costly push method? With this one, we're going to need 2 different queues, Q1 and Q2. What happens is when you add an element, you're actually going to add it to the second queue. Then, if there's anything in the first queue, you empty those out into the second queue, and then you reverse the queues. So it'll look like this. Right now, we've added the element 1 to Q2. Nothing is in Q1, so we won't have to empty that out. Now, we just need to switch these 2 queues. So now Q1 will have element 1 and Q2 will be empty. This is probably not obvious yet exactly how this works, but let me add one more element and it should start to get more clear. So we're at this stage. Q1 has element 1, Q1 has no elements. Let's add another element. So, okay. So the number 2. Number 2, remember when you add an element, you add it to the second queue. Then you empty out Q1 into Q2. So now Q1 will be empty and Q2 will have the numbers 1 and 2. Now you switch the 2 queues. So this will look like this. This will be Q1. Q2 is empty. So now when you want to remove an element, guess which one's going to be removed? It's no longer going to be the first element that was added. It's actually the last element that was added. So before we begin coding, I just want to quickly go over what LeetCode has provided us. So as you can see, there's a myStack class, and it has all the methods that it wants us to implement. So here's the push method. Pushing to a stack just adds an element to the top of the stack. Popping from a stack just removes the top element of the stack. Top just shows the element at the top of the stack, and empty returns whether or not the stack is empty. But what I've gone ahead and done is added a queue class, and I won't go over all the implementation details of this because that's not what this video is about. Just know that all code in this video is linked in the description below. But we have a peek method, and that shows us what's at the bottom of the queue. A size method returns how many elements are in it. Is empty returns whether or not the queue is empty. DQ removes the bottom element of the queue, and InQ adds an element to the top of it. All right, so let's start coding the solution. Remember, the first step is to create two new queues. So this dot primary queue is a new queue, and we'll call the second one the secondary queue. Secondary queue is a new queue. All right, now we get to the push method. Since we're using the costly push way of solving this problem, this is going to be the most involved method, but you'll see that the methods after this are very straightforward. First thing you do when you want to add something is you add it to the secondary queue. So this dot secondary queue dot InQ. And what are we enqueuing? They call it X, so that's where we're going to call it also. Next step is to empty everything that's in the primary queue into the secondary queue. So we'll say while the primary queue isn't empty, meaning there's still things in it, so while it's not empty, this dot secondary queue dot InQ, can't spell InQ, UE, this dot primary queue dot DQ. I'll go over that one more time. So we're checking to see if the primary queue is empty, and if it's not, we're going to DQ, meaning remove the next element in the primary queue, and InQ, so add it to the secondary queue. Final step in this push method is to swap the two queues. So let's create a temporary queue called temp queue equals this dot secondary queue, this dot secondary queue equals this dot primary queue, and then this dot primary queue equals temp queue. So all these three lines do is swap Q1 and Q2, or primary queue and secondary queue. Now, as I mentioned before, the other methods are going to be very straightforward. So now that we've effectively flipped the primary queue, all we're going to have to do is when we want to remove something, we'll say this dot primary queue dot DQ. When you want to see what's at the top of it, this dot primary queue dot peak. Oops, sorry, you have to return these things. Return that and return these. And then if you want to see if it's empty, you would do this dot primary queue dot is empty. And I forgot to return that again. So that just returns whether or not the primary queue is empty. And that should be it. Let's see how we did. Looks good. Now let's submit it. And all right, better than 69% of submissions. So once again, if you want to see this code, it's in the description below. See you next time.